Project ResolVe aims to explore the commercial use of post-consumer polystyrene waste as a raw material to produce high-quality plastics. This video shows how a chemical recycling process for polystyrene looks like and includes interviews from experts.
Plastic waste is currently being recycled via thermal or material recycling processes. And in the ResolVe project, we aim to actually close an economic and ecological cycle. And we as I.A.R. are responsible for the procurement and analysis of plastic waste as well as the targeted pre-treatment for the chemical recycling. Our aim is to provide suitable product qualities and particle size distributions for the following depolymerization. Here we see a bale in which polystyrene is highly enriched. For technical and economic reasons, impurities, like other plastics that impair quality and/or disrupt the downstream process, must be accepted in such a pre-concentrate. But also material moisture and soiling can considerably impair the quality of these pre-concentrates. To ensure that this material can be treated in the depolymerization process without any problems, it must be conveyable, which is not so easy with that very light polystyrene. Good conveying properties are given when the polystyrene has bulk material properties. We achieve this by milling the clean product to less than 30 millimeters.
We are here in one of the laboratories of the Institute for Plastic Processing. In this laboratory, different reactor types can be used in order to depolymerize polystyrene waste. The depolymerization process operates at a temperature range of 350 up to 600 degrees Celsius, in which the polystyrene is thermally overstressed and degrades. The ResolVe project uses a spring screw extruder to study the degradation process and to evaluate different input materials. Compared to conventional extruder, this spring screw extruder is equipped with a high temperature system and is optimized for the output of gaseous degradation products. The recycled material is fed to the extruder via the dosing and the hopper. In the first part of the extruder, the material is heated to its melting temperature. At the first vacuum dome, a vacuum pump removes moisture and oxygen from the process. The actual depolymerization process begins afterwards. The polystyrene is heated far above its melting temperature. This high energy input allows the polymer chains to be broken, resulting in styrene monomer. This is then present in gaseous form and is drawn off from the twin screw extruder with a vacuum via the second and the third domes. The gas is then transported through these pipes into our separator, condenses there and can be bottled as styrene oil. Many impurities and other packaging components, such as aluminium, can be collected separately and be recycled in further steps.
The styrene oil, which you see bottled here, contains, in addition to the styrene monomer, so-called high and low boilers. In order to achieve an enrichment of the styrene, we purify the styrene oil in two consecutive distillation steps. In the first distillation, a rough separation of high and low boiling components with large differences in the boiling point is achieved. In a second step, the intermediate product is further purified by distillation through a column with higher separation efficiency. The styrene monomer obtained can then be used again for the production of high-quality polystyrene plastics. The repolymerization tests are performed at our partner INEOS Styrolution.
We use purified styrene monomer in our R&D lab to test their performance in different polymerization methods we are using in our company. We identify the disturbing impurities and advise our purification partners. We are testing the purified styrene monomer from the pyrolysis oil in radical, both bulk and emulsion polymerization and anionic polymerization. Definitely the anionic polymerization requires high purities and is challenging. In our state-of-the-art pilot plants, we're scaling up the polymerization of recycled styrene monomer to produce sufficient amounts for performance tests and customer sampling. With this R&D program, INEOS Styrolution has brought chemical recycling of styrenic polymers to reality. This research shows that polystyrene is almost designed for recycling. The nice conversion of post-consumer plastic waste back to its original building blocks is a fantastic property of styrenic plastics. We are proud that we can contribute to a more sustainable world by the developments in this research program.
Driving success together.